right triangle also. So there are 6 trigonometric function or trigonometric ratio of a right triangle with an acute angle, which is defined by the two sides of a triangle. The ratio is defined or given by the two sides of a triangle. It can be hypotenuse, opposite, and adjacent. The sides of a right triangle are the opposite, adjacent, and the hypotenuse. When you say hypotenuse, that is the longer side of a right triangle. When we say opposite side, that is the side facing the angle that you're going to solve, and adjacent side, that is the side connected to the vertex of the angle that you were solving. That is the hypotenuse, opposite, and adjacent. So the opposite and adjacent sides refer to another angle other than the 90 degrees. So here are the trigonometric function or trigonometric ratio, which we call the SOHCAHTOA. Sine, tangent, cosine, and secant. Sine has a ratio of opposite over hypotenuse. Cosine has a ratio of adjacent over hypotenuse. Tangent has the ratio which is opposite over adjacent. This cosecant, cosine, and secant, and cotangent are the inverse ratio of our SOHCAHTOA. You have cosine, you have hypotenuse over opposite. Second, we have hypotenuse over adjacent. Cotangent, we have adjacent over opposite. So it's just the inverse of your SOHCAHTOA ratio. So I called it a SOHCAHTOA based on the ratio that you have. If we're looking for the sine, you have your opposite over hypotenuse. If you're looking for the cosine, you have adjacent and hypotenuse. If you're looking for tangent, you have opposite over adjacent. That's why it's called SOHCAHTOA, so that you can easily remember the ratio of your trigonometric function. So let's try. For example, we have this problem applying the SOHCAHTOA or trigonometric ratio. For example, we're going to find the measurement of an angle from the triangle that we have. Find the missing angle from a right angled triangle. We need to know the two of the sides of a triangle. You can then choose the appropriate ratio if it's sine, cosine, and tangent by using your calculator to identify the measurement of the angle from the decimal value of the ratio. For example, we have this triangle. It has a measurement. One side of a triangle measured 14 centimeter and the other side measured 6 centimeter. Looking at the given the measurement of the side of a triangle, we're going to solve for the angle C. What will be the measurement of the angle C? Looking at the measurement, what trigonometric ratio are we going to use? Is it sine, cosine, or tangent? Identify the side of the given in the triangle. This side, since it's longer, so it will stand as your hypotenuse or your H. Since we're solving for this angle, according to trigonometric ratio, the side that is facing the angle that you're going to solve is the opposite. The side facing the angle that you're going to solve is your opposite. And the side connected to the vertex of the angle that you're going to solve is what we call your adjacent. Okay. That's how you can identify the part of the triangles depending on the angle that you're going to solve. Just remember, yung opposite, that is the side facing the angle. Adjacent is the side side connected to the vertex of the angle that you're going to solve. So given that we have the measurement for our hypotenuse and we have the measurement for our adjacent, that means we're going to solve or we're going to use the ratio to find angle C with a ratio of hypotenuse over adjacent or adjacent over hypotenuse. Measurement of angle C. So we're going to use tangent to of adjacent over hypotenuse. So angle C, adjacent is equal to 6 centimeter and hypotenuse is equal to 14 centimeter. So 6 divided by 14,
0.43.
0.43.
43.
But since we're looking for cosine, so cosine 0.43 is equal to, in your calculator, it's equal to 59 degrees. So that is the measurement of the angle C. Tama ba in your calculator? It's 59 degrees.
Ano, teacher?
Na tayo? It's cosine 0.43. That is 59 degrees.
Iba sa amin, teacher.
Iba sa inyo? Ano nangyari sa calculator nyo? Just input cosine, COC in your calculator, COS, and then 0.43 equal sign, and then click the degree symbol in your calculator. This one. Ito. This one. This is the symbol of degree. To make it degree.
Teacher, I have a problem. I don't have a scientific calculator. I always use Google.
Degree, so it will become 59 degrees. Sige nga, can you try to input in your scientific calculator?
Wait, what button was that again, teacher?
COS, cosine. This, you're going to input in your calculator COS 0.43. Then press equal sign. Anong lumabas sa calculator nyo? The COS 0.43. It's 0.999, right? Lumalabas once you input cosine 0.43. Am I correct? 0.99975. Yan ba? Lumabas? Once you press the equal sign. After you press the equal sign, you look for the degree symbol dito sa calculator. Can you find it in your calculator? Can I see your calculator? Sige, we don't want to press the degree.
Your finger through the screen, through the camera, and press the degree.
Not that one. Sige, usog da. Bernadette. Eto, this one. Beside the negative, yeah, that one. That's correct. That is the degree symbol. Okay. Let me see for you, Joe. Did you find it? Yeah, that's correct. You have na. That's correct, Joe. You have 59 degrees. What about you, Chloe? Do you know how to find the degrees na? Okay na? Okay. We have 59 degrees as the measurement of the angle C per our triangle. Let's use the same triangle, but now let's find the measurement of the angle. Let's say this is angle A. So the same triangle, the same measurement for our hypotenuse, but this 6 centimeter will not become your adjacent anymore. Okay. So we have to solve for angle A, the measurement for our angle A. We have hypotenuse, it's the same, 14 centimeter. Your 6 centimeter, since it's facing your angle A that you're going to solve, that will be your opposite. And this side is your adjacent. So based on the given measurement of the side of the triangle, we have opposite and hypotenuse. So we're going to use sine. Sine is equal to opposite over hypotenuse. So we're going to solve for sine angle A, which is equal to 6 centimeter over 14 centimeter, which is the same, which is sine A equal to 0.43. So sine A has a degree measurement of ilang degree? Yeah, the middle one.
0.
0 degree. So you have 0 degree for sine A. It has a measurement of hypotenuse 14 centimeter and an opposite side which is 6 centimeter. So we have 0 degrees for sine A. For example, we're going to find the angle X. We have the side of a triangle that measures 3 centimeter and we have 8 centimeter. So looking at the given, we know that this is the hypotenuse. The side is hypotenuse. The side facing to the angle that we're going to solve is our opposite. The side connected to the vertex of the angle is your adjacent. So given the part of the triangle that we have on the screen, we have adjacent and opposite. So we're going to use the ratio, trigonometric ratio, which is tangent. Tangent is equal to opposite over adjacent. So tan angle X, which is equal to 8 centimeter divided by 3 centimeter, we have a tan X equal to
2.7.
2.7 or 67. So tan 2.7 is equal to 2 69 degrees. So that's how we solve for the measurement of the angle we have using trigonometric ratio. So let's have another example.
Teacher,
Yes po.
for me, I got 2 degrees.
2 degrees.
2 degrees. At again 2 degrees. Shift tan is 2.7. 2 degrees. Have 2 degrees for tan x. So let's say we're going to solve for the side. So, kanina we are solving for the angle. Now we're going to solve for the side of a triangle. Let's say we have this triangle. The measurement of the angle is 30 degrees. We have the side. One of side measures 7 centimeter. And we're going to solve for the side K, the measurement of the side K. Given that we have the angle measured to 30 degrees, this side is your hypotenuse, and K is the adjacent side. Given the parts of the triangle from the ratio of function, trigonometric function, we're going to use the cosine. Cosine is equal to adjacent over hypotenuse. So cosine, angle that has a 30 degrees, equals to the adjacent, which is K, divided by the hypotenuse, which is 7 centimeter. Cross multiply to remove 7 centimeter as the denominator of K. So cosine 30 degrees times 7 is equal to K. So cosine 30 degrees, which is equal to 0.87 times 7 is equal to K, which is equal to 6.1. That's the measurement of the side K. Syntax error. You find first the equivalent of cosine 30 before you multiply it to 7. Cosine 30 equals times 7, so that it will not be syntax error in your scientific calculator.
Wait, teacher, cosine 30?
Yes po. Cosine 30 times 7. That's 6.1 or 6.06.
6.06.
Yes po. Or 6.1 centimeter. Same ba tayo ng answer in your scientific calculator? Okay. Let's use the same triangle, but now we're going to find the measurement of the side A. So the same measurement of angle, we have 30 degrees, and we have the hypotenuse, which is 7 centimeter, and we're going to solve for side A. And this side A is our opposite side, and 7 centimeter is our hypotenuse. So we're going to use the sine trigonometric function. Since we have opposite, over hypotenuse. So sine 30 degrees equals to the opposite, which is A, divided by our hypotenuse, which is 7 centimeter. So sine 30 times 7 equals to the measurement of side A. So sine 30 times 7 is equal to
3.5.
3.5. So that's the measurement of the side A that is opposite to our angle that has a measurement of 30 degrees. For example, we have this triangle. An angle measures 50 degrees and a side of a triangle measures 4 centimeter. And we're going to find the measurement of the side R. What trigonometric ratio are we going to use to find the measurement of side R? Looking at our triangle.
Cosine.
Cosine ba? Are we going to use cosine? Sine, cosine, or tangent? Based on the given that we have. Yes, Cody?
Tangent.
Tangents. That's correct. Yes, it depends on the given. What are you going to use in the trigonometric ratio to solve? So we're going to use tangent since the given that we have is adjacent and opposite. And tangent has a ratio which is opposite over adjacent. So tan 50 degrees equals to opposite, which is R, divided by 4 centimeter, which is here adjacent. So tan 50 degrees times 4 centimeter, which is equal to R. So R has a measurement of
4.8.
4.8 or 4.77 centimeter. So that's the measurement of the side R that we have. So we're going to use a tangent. For example, we have this triangle. Has a measurement of an angle 90 degrees, 45 degrees, and 45 degrees. We're going to solve for the measurement of the two sides of a triangle, which stands for x, and x squared of 2. That's the measurement of each side of our triangle.
Hey,
Bakit okay na? Okay, let's say we're going to solve for the value of x, or the exact measurement of the side, since we have x, x, and x squared. Say we're going to solve for the measurement of x, this one, using the angle, which is angle, let's say this is angle B. So angle B has a measurement of 45 degrees, and we're going to solve for x. Our hypotenuse has a measurement of x, the square root of 2. Opposite side, has a measure of x. And adjacent has a measure of x also. So since we're going to use angle B, so we have hypotenuse over opposite, or opposite over hypotenuse. So we're going to use sine. Opposite over hypotenuse. So sine 45 degrees. Opposite is x. Hypotenuse is x, the square root of 2. So sine 45 degrees times x, the square root of 2, equals to x, or the opposite side. So x square root of 2 times sine 45 is equal to 0.7. So x square root of 2 times 0.7 is equal to 0.x 0.7x square root of 2 equals to x. So the measurement of side x is equal to 0.7x square root of 2. Or we can write it into decimal, getting the square root of 2. Square root of 2 is equal to 1.41. So we can multiply 0.7 x times the square root of 2, which is 1.41, to use the measurement of the side as a decimal. So we have 1.41 times 0.7, which is equal to 0.987x. So you can use radical form or a decimal form if we have a square root in the measurement of the side or in the angle of our triangle. It depends to what you want to use in your answer. I, yeah, I will accept both. Either you write as a decimal, it's fine, or you write it as a radical form. It's okay. Ayun sa radical form. Parang
Decimals,
fraction lang.
no, decimals remain unraveled. Let's not.
You always want
Mm,
decimal. For example, we have this triangle that has a measurement of an angle 60, 30, and 90 degrees. And the measurement of the side is 2x, x the square root of 3, and x. So we're going to solve for the measurement for the value of x. Let's say we're going to solve for the value of x using angle that has a measure of 30 degrees. We have the hypotenuse, which is 2x, and the adjacent, which is x the square root of 3. So let's use the hypotenuse over opposite. So sine 30 degrees equals to opposite over hypotenuse. So sine 30 degrees, opposite is equal to x, hypotenuse is equal to 2x. So sine 30 times 2x is equal to x. So sine 30, which is equal to 0.5 times 2x is equal to x. Which is equal to 1 or 1x. Means the value of the side x is equal to 1. Since 0.5 times 2 is equal to 1, so the measurement of the opposite side of the angle 30 degrees is equal to 1. So finding the hypotenuse in a 45-degree angle. Say we have the measurement of the side of an angle, the same, which is equal to 3. And the hypotenuse stands for the missing measurement, which is x. So we're going to use, yes po. From the 30 degrees, it depends on the angle that you're going to use. So since here, for example, if you want to use this angle to find the hypotenuse, what ratio are you going to use? It can be either to use the side, you can use 2 ratio since you have adjacent over hypotenuse, or you can use the other ratio which is opposite over hypotenuse using this angle. Okay. Depending on the part of the triangle that you're going to use to find the missing side or the missing angle. So for example here, since you have 2 possible ratio that you can use in finding the hypotenuse, you can use adjacent over hypotenuse, which is stands for your cosine, and opposite over hypotenuse, which stand for your sine. So you can use this 2 ratio to find the measurement or the value of x in the triangle. Since 45 degrees has its opposite, this is your opposite, and this is the adjacent. Or you can use this one, it's the same, since you have the same measurement of the angle, which is 45. Same din ang measurement, you have the same measurement for the side, both side of the triangle, which is equal to 3. It's the same value. So we're going to use, let's say we're going to use the cosine first. Let's see if we're going to have the same answer, whether of the 2 ratios we're going to use. So we have cosine 45 degrees, which is 3 over x. It's the hypotenuse. So cosine 45 times x equals to 3. Since we're solving for x, or the measurement of the hypotenuse, so we're going to divide both sides by cosine 45. So we have x equals to 3 divided by cosine 45, which is equal to 4.24. That's the measurement of the hypotenuse. So let's try using the sine. So sine 45 degrees equals to the opposite, which is 3, and the hypotenuse, which stands for the x. So sine 45 times x, cross multiply, we have sine 45 times x equals to 3. Since we're solving for the value of x or the hypotenuse, divide both sides by sine 45. So x equals to 3 divided by sine 45, which is equal also to 4.24. So either of the two ratio that we have, but as long as we have the same measurement of the angle and the same measurement of the side, you will be having the same answer for the hypotenuse when we are solving for hypotenuse or the other measurement of the side of the angle or triangle. So the measurement of the hypotenuse is equal to 4.24. Question in this example that we have. Okay, let's have another example. Can I clear the screen? Okay na for this example?
Wait po, teacher.
Wait.
Just copy.
Sige.
Teacher, can we have more examples tomorrow?
Tomorrow. Sige. We're going to have examples for a real application. Word problem of trigonometric ratio.
Teacher, we're already mixing these shapes with numbers and letters. That's already revolutionary. And now you're mixing it with sentences. That's a madness.
We're going to use it in the word problem na. Okay na, can I clear the screen? Okay na, Charles?
Yes po.
Okay.
Yes.
For example, we're going to find the side of the triangle, which is P and S. So we have two missing measurement of the side of our triangle. And we have the measurement of the angle, which is 30 degrees, 60 degrees, and one of the side of the triangles is measured with 5. Okay, let's start in solving for the measurement of S, the side S. So if we're going to find side S, we can use this angle or we can use this angle. Your answer will be the same. Either of the two. To find the measurement of side S, you will be having the same answer. You can use the angle measured 60 degrees or you can use measured angle 30 degrees. Okay. Let's say we're going to use the angle 30 degrees. So if we're going to use this 30 degrees angle, looking at the side that we're going to solve, which is side S, and we have the given measurement of the side, which is 5. So we have the ratio, which is opposite over adjacent for angle 30 degrees. And that is tangent. Opposite over adjacent as a ratio of your tangent. So tan 30 degrees, opposite is your side S, and adjacent is 5. So tan 30 times 5 equals to the measurement of side S. So tan 30 times 5 is equal to 2.9 for our side S. So we have the measurement for side S, which is 2.9. So we can now proceed to the second missing side of our triangle, which is side T. So looking at, since T is our hypotenuse, so let's say we're going to use the 60 degrees, or if you still want to use the 30 degrees, it's fine. Okay? It's either of the two of this 2-degree angle going to use, as long as your ratio is correct, you will be having the same answer. Let's say we're going to use 30 degrees again. So 30 degrees, we have the hypotenuse, we're going to use the adjacent. Adjacent over hypotenuse. Adjacent over hypotenuse has a ratio of your cosine. So your adjacent is equal to 5, hypotenuse is equal to t. So cosine 30 degrees, cross multiply. So cosine 30 times t equals to 5. Divide both sides by cosine 30 degrees to find the value of t. So t is equal to 5 divided by cosine 30, which is equal to 5.8. So that's the measurement of our hypotenuse. 5.8. Okay na, for this example, can I clear the screen? Let's say we have this triangle. And we're going to solve for angle A. If the given measurement of the side of the triangle is 3, 4, and 5. So let's say we're going to solve for angle A. What trigonometric ratio do you want to use to find the measurement of angle A, given that all the side of the triangle is present? All of the side has a measurement.
Cos.
Cos. So Charles want to use the cosine ratio. So cosine ratio has a ratio of adjacent over hypotenuse. So if we're going to use the cosine, so cosine A, angle A, our adjacent is 3, hypotenuse is 5. So cosine A, 3 divided by 5 is equal to 0.6. Cosine 0.6 is equal to how many degrees? 59 degrees. So the measurement of the angle A, is equal to 59 degrees. You can either use, since all the measurement of the angle, all the measurement of the side of the triangle is present, you can choose to use sine, you can use to choose tangent. And the answer of the measurement of the angle will be the same. Since we have the same given measurement for each side. Okay? So, when you are solving using trigonometric ratio, just identify the parts of the triangle and the ratio that we have. Identify the given first. If you're solving for a triangle for the angle, if the given, for example, this one is not present, if the given is only these two, identify the parts of the triangle if we're going to use or to solve for this angle. You have your opposite. This is your opposite since it's facing your angle that you're going to measure. And we know that hypotenuse will remain as the longest side of the triangle. So that's the only one that you're going to identify. If it's opposite or adjacent, so that you will know what trigonometric ratios you're going to use. Okay? So, okay. Tomorrow, we're going to have some examples in a word problem. Solve trigonometric ratio. Since the one that we have today, it's just figure of a triangle. So tomorrow it's in the word problem, applying trigonometric ratio. Okay. So I think that will be all for this afternoon. We're just going to continue it tomorrow. Goodbye, everyone, and see you tomorrow. Bye.
Bye.